Alrighty, moving right along through chapter 2. This section is on literal equations and dimensional analysis. Literal equations is a fancy name. Here we go, first vocab word. It's a fancy name for an equation that has more than one variable. So a lot of times you'll be solving an equation with just one variable, say x, and you can solve for x by following the golden rule and PEMDAS and simplifying stuff. And at the end you get an answer, x equals 5 or x equals -2. You get some numerical value for x, and that's the solution to that equation, which makes the equation true. On the other hand, a literal equation with more than one variable, you can often think of it as a formula. So you can rearrange the equation and get any particular one of those variables by itself, but you're never going to get out a numerical answer because there's more than one variable in the equation. So this is probably one of the most important topics in all of Algebra 1, and it's the one that will apply most in your other classes, like science, for example. You'll be having equations with more than one variable. For example, velocity equals distance over time. That's an equation that has three variables, one for velocity, one for distance, one for time, and you can rearrange it and use it to find any of those three quantities. Okay, next vocab word, dimensional analysis, or also called unit analysis. So this is a process of including units, and by units we mean, like, if it's distance you might have feet or meters or miles. If it's time you might have seconds or minutes or hours. If it's speed it might be miles per hour or meters per second or something like that. So the units are the type of measurement that you're doing. By showing the units on your calculations, you can kind of figure out what to do or cancel them out and make sure that they come out correctly. This is a big part of science, especially chemistry and physics, and they put the vocabulary word here in this section for your textbook because it comes with formulas. However, I will tell you that this is not focused on in this section. Later on in the year we'll probably come back to it and focus on it more, but in this section it's not really focused on. Okay, what are your problem solving tips? When you have a literal equation, something with more than one variable, what's your strategy? So the first thing is, solving the equation is exactly the same steps as if there was just one variable. You simplify each side using PEMDAS, combine like terms, distribute into parentheses, reduce numbers, etc. Then you also follow the golden rule to do the same thing to one side as you do to the other side, to keep simplifying and keep simplifying. The only thing is, when you add or subtract something from both sides, or you multiply and divide both sides by the same thing, instead of adding and subtracting numbers, or multiplying and dividing by numbers, you could be adding and subtracting or multiplying and dividing by other variables, other letters. But the way in which you do it is the same. I could add 5 to both sides, or I could add the letter P to both sides. The way you do it is the same. The last thing is, sometimes a little trick occurs where the variable that you're trying to solve for shows up more than once, and sometimes you need to factor it out. So if we get some examples where that occurs, I'll talk about it in more detail. Alright, here's some examples. Solving multivariable equations. So this first equation, circumference equals 2 pi r. This is the circumference of a circle. So let's solve the equation for r. Suppose you know the circumference and you're looking for the radius. Well, here's the r. To solve for r, we want to get r by itself, so we need to divide by 2 pi. If we divide by 2 pi, the 2's cancel and the pi's cancel. The golden rule says if I divide this side by 2 pi, I also divide this side by 2 pi. And that's it, we're done. R is now isolated, equals circumference divided by 2 pi. So we've rearranged this formula. It's still the same formula, it still contains the same information. We've rearranged it though, so now it's solved for the radius instead of being solved for the circumference. Okay, here's another equation, E equals mc squared. This is a very famous equation from Einstein, you might have heard. E is standing for energy, m stands for mass, and c stands for the speed of light, and then we're squaring it. So if we want to solve for m, we want to get m by itself. The m is being multiplied by c squared. So to cancel that out, we have to divide by c squared. C squared is just one something. You know, if we knew a number, if we knew that c was 3, this would just be the number 9, right? So we're just dividing by whatever that quantity is. It's c squared. Cancel, cancel. So m equals e over c squared, and that's your answer. So you're just rearranging is really what you're doing. And notice in both these equations, I switched the left side and the right side, so my single variable I write on the left-hand side. That's just a standard way to write a formula, is to have the thing that's solved for by itself on the left. Alright, keep going. Solving multivariable equations, keep going. Solve for y. So in this equation we have both x and y. In fact, this is an equation of a straight line, a linear equation. But to solve for y, we want to get y by itself. So right now we have a 6x and a 4y. You might think this y is multiplied by 4, so I want to divide by 4. And that's true. You will eventually divide by 4, but remember, when we're solving equations, we do PEMDAS backwards. So the first thing to do is to get rid of this plus 6x here. How do we get rid of a plus 6x? We minus 6x, because 6x minus 6x cancels out. If I subtract 6x here, I also need to subtract 6x here. So those cancel. On this side, I just have a 4y equals. Now here, be careful. A 28 minus a 6x. We cannot combine those together because they're not like terms. This one is a 6 times x. That has a variable in it. This is just a number. So you could write 28 minus 6x, or you could write negative 6x plus 28. The reason I'm writing it this way is standard notation puts the variables in the front and the numbers in the back. Now, our last step is to divide by 4, just like normal. But remember, this is the part that a lot of students might forget about. The golden rule says if you divide one side by 4, you have to divide the entire thing by 4, yeah? So we're dividing the entire thing by 4. That means we're dividing the first part by 4. What's this part here? Negative 6 over 4 reduces to negative 3/2 times x plus 28 divided by 4 also reduces to what? Half of 28 is 14, half of 14 is 7, so plus 7. And this technique of dividing both things in the numerator by whatever is in the denominator, I call this the butterfly technique because it looks like a butterfly. So anytime you hear me say butterfly technique or butterfly that problem, what I mean is remember that everything in the numerator is being divided by whatever that number is in the bottom. So we have to do it multiple times. Okay? So final answer, y equals negative 3/2 x plus 7. Alright, last example. Solve for b. Here, notice I have a b right here, and I also have a b right here. So we're going to need to get all those b's together on one side and move everything else away to the other side. But the first thing is to simplify each side as much as possible. This left-hand side, I can distribute the 5 in here. So I'm going to get 5a plus 5b minus 2a equals 10 plus b, yeah? Now here I can combine the 5a and the negative 2a. What's 5a minus 2a? That will give me 3a plus 5b equals 10 plus b. Now I'm solving for b, so I'm going to get all the b's together. I'll do minus b minus b. Those will cancel out. So now I have 5b minus 1b is 4b. And I know I'm going to have to move this 3a away, so I might as well do that all in the same step. Minus 3a minus 3a. Okay, cancel here. So on this side I had 5b minus b, which is 4b. Over here I have 10 minus 3a. Again, I'll write the minus 3a at the front, and then plus 10, just to put the variables in the front and the numbers at the back. Last step, divide by 4, divide by 4. Okay, 3 doesn't divide by 4 evenly, but 10 does divide by 4, or reduces. So I'll separate this apart, again, doing this technique I call the butterfly. So my final answer is b equals negative 3/4 a plus 10 reduces with 4. 10 divided by 4 is 5/2. And you wouldn't want to write 2.5 because if you write a fraction here, you also want to write a fraction here. So you want to choose either fractions or decimals and stick with that in any given equation or problem. Alright, so in class we'll do lots more of these examples, some a little harder than this, that combine multiple steps, combining like terms, etc. But I hope this gives you an idea that solving equations with more than one variables follows the same procedure and steps as solving equations that we've been doing a lot this chapter. Alright, I'll see you in class.